Fresh data on the asteroid Apis has raised concerns among scientists, with NASA cautioning that the asteroid could alter its orbit in 2029 and potentially collide with Earth 7 years later. In response, governments and space agencies worldwide are collaborating to develop a unified planetary defense system. Preparation is crucial because, even if Apis bypasses us this time, it's only a matter of time before another space rock threatens our planet. Diary of a Global Catastrophe. June 2004, The Discovery. An otherwise routine night for astronomers took a dramatic turn when researchers at the Kitt Peak Observatory detected an unusually bright object in the sky. The asteroid, officially designated 99942 Apis, was swiftly identified as one of the most hazardous near-Earth objects ever recorded. Even the initial trajectory calculations left scientists stunned, and impact in 2029 remained a real possibility. For the first time in modern history, humanity faced the looming threat of cosmic catastrophe. This is no ordinary space rock, a concerned scientist remarked in an early statement. Measuring approximately 340 meters in diameter and weighing over 27 million tons, the asteroid's impact would unleash energy equivalent to 655,000 Hiroshima bombs. July 2004, First warnings. A thorough analysis of all available data on the asteroid sparked widespread panic. The likelihood of an impact was calculated at a troubling 2.7%, the highest probability ever recorded on the Turin scale, which assesses asteroid collision risks. Apis received a rating of 4, an unprecedented score for any celestial body. The Turin scale, which ranges from 0 to 10, categorizes threats accordingly. Values between 0 and 2 indicate negligible risk, whereas a level 4 rating signals a genuine hazard. A score of 10 represents a catastrophic, world-ending event. Once the findings were made official, media outlets reacted swiftly. Headlines such as Apis, the doomsday asteroid and is this the end of humanity, dominated news cycles worldwide for weeks. Governments scrambled to form crisis teams, while various organizations and religious groups. In 2005, extremists predicted the end of the world. However, by the summer of that year, reassuring news emerged. More precise calculations, backed by new data, indicated that Apophis was likely to pass by Earth in 2029 rather than collide with it. The asteroid was expected to come within approximately 31,000 kilometers, closer than geostationary satellites, which orbit at around 36,000 kilometers. Yet, the threat was not entirely eliminated. Experts cautioned that the 2029 flyby could alter Apophis's trajectory. If the asteroid traveled through a specific narrow region in space, known as a gravitational keyhole, its orbit could shift significantly. While this keyhole is small and the likelihood of Apophis passing through it is even smaller, the possibility cannot be completely dismissed until its exact path in 2029 is determined. If the unimaginable were to occur, the asteroid would be set on a trajectory leading to impact in 2036. Since that realization, NASA and world governments have been making preparations. We cannot afford to wait passively, we must take action now and develop a unified global defense strategy. Apophis is not the only threat. Hundreds of asteroids pose potential dangers to Earth. The day will come when one of these space objects collides with our planet, and as an advanced species, we cannot simply stand by. Missions like DART and the OSIRIS probe have demonstrated our capability to defend against such threats, but we need time and experience. In a crisis, an effective defense. If AUS remains on a collision course in 2029, action must be taken in time and with utmost safety. The process will take 7 years. On April 13, 2029, a Friday that may prove ominous, the world will witness a pivotal moment. Millions across the globe will gaze at the sky, aware that a 340-meter-wide asteroid holds the fate of humanity in its path. AUS will shine as brightly as a star, visible even to amateur astronomers without telescopes. This massive asteroid will streak past Earth at an astonishing speed of 30,000 kilometers per hour. During this period, astronomers will aim the most advanced telescopes and radar systems at the object. This flyby is more than just a visual event, it presents a rare opportunity to closely examine AUS. Gaining detailed insights into the asteroid's composition and structure is crucial, especially for potential defense strategies. NASA and ESA are considering deploying probes to AUS for in-depth measurements and observations. The OSIRIS-APEX mission is currently en route to Apis. Having previously collected samples from asteroid Bennu, the probe is expected to return rock samples from AUS to Earth in the coming years. By April 2029, we will know definitively whether Apis has passed through the gravitational keyhole. Updated orbital calculations will then determine if we can expect another close approach in 2036 or if active measures will be needed to protect our planet. May 2029, both a relief and a cause for concern. By then, the most precise new calculations will be available. If AUS has passed through the keyhole, humanity will embark on an unprecedented level of preparation. International crisis teams, consisting of politicians and scientists, will strategize defense measures. Engineers will develop probes, and within 7 years, we should be capable of altering the asteroid's trajectory. NASA's DART test proved this concept by successfully redirecting the mini-asteroid. However, if AUS passes through the keyhole, two outcomes are possible. Either humanity will have successfully altered an asteroid's course for the first time, using a probe similar to DART or towing it with other spacecraft, both currently considered the most promising strategies, or we will witness a historic achievement. In that case, Earth will celebrate its scientists, along with the thousands of engineers and technicians who made this feat possible, taking pride in our ability to protect ourselves. If our defense efforts fail for any reason, disaster could follow. While an asteroid the size of AUS wouldn't destroy the Earth, it could still trigger a global catastrophe. The immediate destruction would be regional, but if the impact occurs in water, massive tsunamis could threaten coastal areas worldwide. A collision with the Earth's crust would set off global earthquakes, potentially rupturing fault lines like the San Andreas Fault. Supervolcanoes such as Yellowstone or Italy's Flugon Fields could erupt, sending rock and dust high into the atmosphere, drastically altering the climate. This could lead to prolonged darkness, extreme cold, widespread crop failures, food shortages, and even conflicts among nations. History provides a stark warning. 60 million years ago, an asteroid about 15 kilometers in diameter struck near present-day Mexico, leaving a massive crater and triggering an environmental disaster so severe that it wiped out the dinosaurs. Although Apophis, at 340 meters in diameter, wouldn't cause human extinction, its impact would still be devastating. Modern civilization is highly vulnerable due to our reliance on technology, electricity, and infrastructure. Additionally, humanity has yet to achieve global cooperation and peaceful organization. A disaster of this magnitude would be an immense challenge for society. Scientists continue to stress the urgent need for asteroid defense technologies. Strategies like deflecting an asteroid through kinetic impacts or laser interventions are actively being researched, though many of these concepts are still in their early stages. 2068, a glimpse into the future. Surviving Apophis was only the beginning. Humanity's challenges are far from over. The asteroid served as a wake-up call, reminding us that space, while breathtakingly beautiful, is also filled with hidden threats. Even though Apophis spared us, the risk remains. At any moment, a new asteroid, larger and more dangerous, could be discovered. One thing is certain, we have taken this warning seriously. By 2068, we may already have a robust planetary defense system against asteroids. NASA could possess an arsenal of emergency probes ready to launch at a moment's notice to intercept any looming threats. In this envisioned future, our defenses may go beyond just multiple DART-like probes. We might also have advanced towing probes capable of docking with asteroids and altering their trajectories. Asteroid defense could become a unifying force for nations worldwide. NASA is not alone in pioneering these efforts. Japan's cutting-edge probes are making significant contributions to asteroid research, while their advanced technology is reshaping lunar exploration. India and China are emerging as major players in space travel, and the European Space Agency, ESA, has successfully landed a probe on an asteroid, with more missions in the pipeline. Meanwhile, laser technology may have progressed to the point where a network of high-powered lasers is positioned atop the world's highest mountains. With multiple beams, 3, 5, or even 10, converging in orbit, they could create a powerful force capable of vaporizing incoming asteroids before they pose a threat. However, despite these advances, one question remains: are we truly safe? Experts caution that even the most advanced technologies may not protect us from smaller asteroids that evade detection. A stark reminder of this occurred on February 15, 2013, when the Chalab-bin asteroid appeared without warning at 9:20 a.m. local time. It exploded in the atmosphere, and the resulting shockwave shattered windows across Russia, demonstrating the unpredictable dangers that still lurk in the cosmos.